Welcome back in. We are just going to do a couple more examples with function composition. So here we have functions f and g. We want to find g of f of x and its domain. Okay, so again, the domain is always secondary in my mind because I like to look at um, the composed function itself. So if I look at g of f of x, right, this is equal to g, and then inside of g, I like to write big parentheses with little f of x inside. Okay, so g, and then into g, I insert square root of x minus 1. Okay, and then this goes in for the x and g of x, so I get 1 over square root of x minus 1 all minus 3. Okay, so I got my composed function. Now I want to find the domain of f. Okay, domain of f, since I have a square root, right? X minus 1, whatever's underneath the square root, has to be greater than or equal to 0. So that means x has to be greater than or equal to 1. Okay, so I can picture that. Now in this second one, or I also need to look at the domain of the output and make sure that's defined, right? So in here, right, I need the denominator to be not 0. So square root of x minus 1 all minus 3 cannot be 0. Okay, so then I solve this. Square root of x minus 1 is equal to 3. Square both sides. X minus 1 cannot equal, oops, that's cannot equal, cannot equal 9. So then x cannot equal 10, right? So, okay, I have the two conditions that I need to intersect, right? So on a number line, right, here 0, I need everything that's 1 or larger is another condition. And then for the output, right, it's saying that x cannot equal 10, but I can have every other number on the real number line. That's interesting, okay? But again, the domain needs to satisfy, the domain of the composition needs to satisfy both conditions. So again, it's both conditions are satisfied at 1 up until 10. We need a break, and then everything after 10 would be satisfied as well. Okay, so then the domain of g of f would be, actually I'm going to do colon. Let's see, 1 with a bracket, up until 10, parentheses, union 10 to infinity. Okay, so again, for the domain, look for the domain of the input, okay? Look at the domain of the output and find the common values in those two domains. All right, last example here. Okay, we have two functions. Find the two compositions and then which one has a larger domain? Oh, that's an interesting question. Okay, so I'm just going to maybe go a little bit faster. So f of g, right? This is saying into f insert g, so square root x in its place, we insert x squared plus 2 and then minus 2. Okay, if I just go through and simplify that, then I can remove the parentheses. This would be end up being square root of x squared. Now, by definition, you'd want to say it's x. It's actually the absolute value of x. Okay. Yeah, because of the square inside, we don't know whether x was positive or negative in the beginning. So there we go. That's why we have to do absolute value. G of f, on the other hand, we are taking f and inserting it into g. So again, x is right there in the g function. So in its place, we're inserting square root of x minus 2, squaring that and adding 2. And if I simplify this, I get, let's see, so the square and the square root would cancel. Now in this case, I don't need an absolute value because the square root is already inside, so it's forcing it to be positive, and then I square a positive and I get a positive. So this would be x minus 2, all plus 2. So this is equal to x. Okay, so very similar things. Which one has a larger domain? Okay, we need to be careful with this. The larger domain question, okay, so here I need to find the domain of G and intersect it with the domain of the output. Okay, so this is going to be domain of G was all real numbers, and I would need to intersect that with the domain of the output, okay, which square or absolute value of x is also all real numbers. So then the domain here is all real numbers, okay. Absolute value of x is defined for all real numbers, and then again the input, this x squared plus 2, that was defined for all real numbers as well. Looking at g of f, okay, so I need to do d of, or find the domain of f, intersect that with the domain of the output. Okay, this is going to equal domain of f, okay, that was the domain of the input, would be everything that is 2 or larger, and intersect that with the domain of the output, which is all real numbers. Okay. Now you can confirm, but this is going to be from 2 to infinity for the domain when I intersect them, when I look at their common values. Okay. So just because you get very similar things, because we're going through function composition, sometimes our domain gets narrowed due to the intersection of the domains. So just be careful of that. That was the key takeaway from all of this, and also the reason why the domains matter so much. We get very similar outputs, but the domains are very different.